This is part 2 of the series Three-Dimensional Solids. In this part we're going to start out by taking a look at lateral and surface area of prisms. Before I do that, I'd like to give a detailed breakdown of the different parts of a prism. We looked at prisms a little bit in the last part, but I want to go through a little bit greater detail in this part. So let's break down each one of the different pieces. The first piece I want to talk about is the base. The bases are congruent parallel polygons. So you can see this base is a pentagon and this is a polygon. These two polygons are in parallel planes. So these are the bases, the congruent parallel polygons. These side faces are called lateral faces. A detailed description here is in a prism, the side faces or lateral faces are parallelograms whose vertices are corresponding vertices of the bases. So this vertex corresponds to this vertex corresponds to this one. This is a parallelogram. And the same for all these other lateral faces. So we have bases and then we have lateral faces. The edges that connect the lateral faces are of course called lateral edges. So these are all the lateral edges, and it's just a segment connecting two corresponding vertices of the two bases. Now the lateral area of this object is the sum of all the areas of the lateral faces of the prism. So the lateral area or lateral surface area, I try not to use the term surface area when I'm discussing lateral area because it can be confusing when you see the definition of surface area. But the lateral area is the area of all the lateral faces put together. And the surface area of the prism is the lateral area plus the area of both of the bases added in. So you would sum up the areas of the lateral faces, then you would find the area of one of the bases and multiply that by 2. And you can multiply that by 2 simply because these bases are congruent bases. It may seem a little redundant, but I want to reiterate the distinction between lateral area and surface area. Lateral area is just the area of the lateral faces. It does not include the area of the bases. Surface area is the lateral area, that is the area of all the lateral faces, plus the area of both of the bases added in. So when you see something requesting surface area, that means everything. The area of all the lateral faces and the area of the bases. When you see lateral area or lateral surface area, that is just talking about the area of the lateral faces. So I just wanted to make that distinction because it's a source of error for a lot of people. Now, dealing with the orientation of the lateral faces as they relate to the bases, there's two basic conditions. If each lateral face is perpendicular to their bases, in that case, that prism is called a right prism. So all the lateral edges are perpendicular to the bases in a right prism. Now we have another kind of prism where you can basically take one of the bases and slide it to the side, and therefore the lateral faces, the lateral edges are no longer perpendicular to each one of the bases. That's called an oblique prism. And so here you can see that the lateral edges are no longer perpendicular to the bases. It's just like you just slid this base over to one side. So there's a distinct difference between right prisms and oblique prisms. And the same is going to be true for each one of the other shapes that we look at, cones and cylinders and pyramids. To actually find the lateral and surface area of a prism, there are a couple of methods. One method that people like is to actually take apart the prism and create what's known as a net. That is, unfold all the sides and connect them by one edge so that you can see the different pieces that make up the prism. And that's called a net. So I'm going to take a look at the net of a rectangular prism just to give you an example of what we're talking about. Now here I have a rectangular prism, and I'm going to go ahead and unfold this thing. But before I do, why don't you see if you can draw what you think this would look like if you unfolded? That is, unwrapped this thing and laid this thing out flat. Take it from a three-dimensional solid to a bunch of two-dimensional polygons connected. When you're done, come back to the video. Now I'm going to go ahead and unfold this solid and see if my net matches yours. Here we go. Now as you can see, all the pieces are unfolding and we've created this thing that looks like this. So I don't know if that matched what you had, but now to find the lateral or surface area of this thing, that's all you have to do is add up the areas of each one of these polygons. And it makes it a little easier until you develop some spatial reasoning skills to be able to do this while it's put back together. But it's just a little interesting aside there. So I'm going to fold that back up again, and you can see what was the original shape again. Now that we've looked at the net of this prism, let's go ahead and actually calculate some values with an actual example. Here's our first example. We have a rectangular prism. We have a length of 5 units, a width of 2 units, and a height of 3 units. Now to find the lateral area, you can just find the areas of all the individual polygons and add them together, or you can apply a small basic formula. If we take a look at this, if we had 5 times 3 plus 2 times 3 plus 5 times 3 plus 2 times 3, you'll notice that every one of these has a multiple of 3 in it. So what we can actually do to simplify this process is we can just find the perimeter of this. So find the perimeter of one of the bases and then multiply that by the height. And that's going to give you the lateral area of your prism. Here's your formula. Lateral area is perimeter, the big P is perimeter times height. And then the surface area would be that lateral area plus 2 times area of the base. This big B is going to be a common thing that we're going to use. Big B is always going to be area of the base. As opposed to a small b would be the length of a base. So this big B is area of the base. Now an alternative to this is we could construct the net of this prism and calculate appropriately. Here's the net of the prism, and as you can see, there'd be a little bit of work after you've drawn it to label the different pieces, and you'd kind of have to do that in order to make use of it. But if you're having difficulty at first unpacking this solid and applying the formulas, this might be helpful to you. So let's go ahead and calculate the lateral and surface area of this prism. I'm going to use this formula to calculate the lateral and surface area of this prism. So let's start. Lateral area is equal to the perimeter times the height. So that gives us the perimeter is going to be 5 plus 2 plus 5 plus 2. 5 plus 2 plus 5 plus 2. And that whole thing is going to be multiplied by the height. The height is 3. So this is 14 times 3, which is 42. Now we calculate surface area. Surface area is equal to the lateral area plus the area of the base times 2. So we have 42 plus 2 times the area of the base. So area of the base is 5 times 2, or 10. So here we have 42 plus 20, which is 62. And there's our surface area. So we just did lateral area, perimeter times height, gives us 42. Surface area is lateral area plus 2 times area of the base, 62. Let's go ahead and work another example. In this problem, we have a regular pentagonal prism with a base length of 6 and a height of 8. Now this is going to require a bit more work because we're going to have to find the area of a regular polygon. And if you remember that from our last unit on finding areas of regular polygons, this is going to take a little bit extra work. So let's go ahead and start off by finding the lateral area, because that should be a little bit easier. Let's go ahead and say lateral area is equal to perimeter times height, which is equal to 6 times 5. 6 times 5. And then times the height, which is 8. So 6 times 5 is 30, and 30 times 8 would be 240. Now to find the area of regular polygon. I'm just going to show you my preferred way. If you have another way, please feel free to use it. But what I'm going to do is I'm actually going to draw a triangle inside here. That's the triangle that you're going to solve. I do this for every one of the regular polygons. I just draw that one triangle, and everything else can be derived from that. So I'm going to go ahead over here and I'm going to draw that triangle so that we can reproduce it. Doesn't have to be pretty, doesn't have to be elegant. So I'm going to put in the apothem. We know that apothem is perpendicular to that base, and we know this base is 6. Now in order to find the area of this thing, we know that area of a regular polygon is 1/2 perimeter times apothem. So we can find the perimeter. We already know the perimeter is 6 times 5. So that's all we really need is the apothem, which is this guy. Now since we know that this is 6, we know this little side length here is 3. Now since we don't have the hypotenuse, we're going to have to do some trig to find that value. So the first thing we need to do is go ahead and find our central angle. Now since we have 5 sides in our polygon, we know we have 5 central angles. So to find the measure of one central angle, we take 360 divided by 5, and that gives us 72. So this whole angle is 72. That means this angle has to be half of that, which is 35 degrees. So let's go ahead and find our trig function. Some old horse caught a horse taking oats away. Tangent. So tangent 35 equals 3 over a, and therefore the apothem equals 3 over tan 35. And that's approximately equal to 4.28. Now I'm going to go ahead and store that in my calculator so that I can use it in my calculation. That means that the area of the base is equal to 1/2. The perimeter is 6 times 5, which is 30, times apothem, 4.28. That's a 2. And that's going to be approximately equal to 64.3. Now, I'm going to put this all together. So, surface area equals lateral area plus 2 times area of the base, which is 240 plus 2 times 64.3, which is approximately 368.5 5. That'll wrap it up for this part, and I'll talk to you again in the next video.